Hi, today we're talking about scale effects on volume. So our first shape is a cube with all three sides equal to 3. So first we need to find our original volume. So remember it's the area of the base, which is 3 times 3, times the height, which is also 3. So we could abbreviate that to 3 cubed. 3 times 3 is 9, 9 times 3 is 27. So we get 27 yards cubed. So remember, our units are cubed because our volume is cubic. That's going to play into effect later. So our scale factor, this is the percentage that we are using to change it, multiply it, 40%. Now that may look like, oh, we're growing it 40%, but not exactly, because 40% in decimal form equals 0.40, if you will. Okay, so this 0.40, it's less than 1. It's less than a whole. So if we multiply a number by less than 1, then it decreases that number, right? So predicted the volume will increase or decrease. So if we multiply the volume by a smaller number, it's going to decrease. So we're going to predict that this is going to decrease because our scale factor is less than 1. So let's look at our new volume. Now we can't just multiply 27 yards by 0.4. It doesn't work that way. We could do that if it were, say, like the perimeter. But remember, volume is cubic. So our scale factor needs to represent that. So we're going to say our new volume equals 0.4 cubed times our original volume of 27. Now the reason why we cube our scale factor is because if we multiply the scale factor by the side lengths, so if we multiply 3 by 0.4, and we found our new side length, and then to find our new volume, we would take that new side length and we would cube it, right? So we're doing the same thing, we're just not going all the way back to changing each side length, we're just going to affect the volume. It's like a shortcut. Okay, so 0.43 cubed is roughly 0.064. And then we still times 27. So when you multiply all that out, we're going to get 1.728. Wow, that's a lot smaller than 27, right? And this is still going to be yards cubed. Okay, so it didn't just decrease it by 40%, it actually decreased it by 6.4%. A lot. Okay, let's pick a new color. This is a cylinder, so the volume is going to be the area of the base times the height. Don't know what that's about. Okay, the area of a circle is pi r squared, so pi r is our radius, 4 squared times the height, which is 10. Okay, 4 times 4 is 16. 16 times 10 is 160. And we are going to leave this in terms of pi because it's just a lot easier. It looks better. And this will be feet cube. Okay, scale factor of 2. This is a nice whole number. It's greater than 1. It's doubling all of our side lengths. Okay, so if we're increasing everything by 2, our volume's going to increase also. Not by 2, but it's going to increase. So again, we're going to have to cube the scale factor. So our new volume be 2 cubed times our original volume, which is 160 pi. Okay. 2 cubed is 8, 2 times 2 is 4, 4 times 2 is 8. So really we're doing 8 times 160 pi. And that equals 1,280 pi feet cubed. So you should have already learned doing perimeter and area. So like area, your units would have been feet squared, so you would have squared your scale factor. Now we're doing feet cubed, so we're cubing our scale factor. They all kind of correlate. Okay, so let's find this prism. Okay, 7 times 6 times 1. Okay, well, anything times 1 is itself, and 7 times 6 is going to be 42. So that's 42 inches cubed. Okay, our scale factor is 5/2. Well, that's the same thing as 2.5. Okay, that's greater than 1, so we're going to increase. So our new volume is going to be 2.5 cubed. Remember, we can't just use it by plain. Times our original volume, which is 42. Okay. 2.5 cubed is 15.625. And guys, you don't have to simplify it. You can just plug it into a calculator like this, and you'll get the same thing. Just want to show you all the steps. So we multiply this out, we get 656.25 inches cubed. Okay, so notice where we predicted decrease, we went from 27 to 1.728. We predicted increase, 160 pi to 1,280 pi. 42 inches cubed to 656 inches cubed. So where we're increasing, predicting increases, we're seeing them. Where we're predicting decreases, we're seeing that as well. So how is volume affected by the scale factor? Okay. Well, the volume either increases or decreases the volume. Sorry. Increases when the scale factor is greater than 1. And decreases when the scale factor is, I don't want to say less than 1 because we're not going to have a negative, but if it's a fraction, we'll say fraction. Okay, yay. And as always, let me know if you have any questions, email or Google Classroom. Okay, have a great day. Hope you guys are doing all right out there. Okay, bye-bye.